This video is on roots and radicals. So this is going to be the first part of an introduction on roots and radicals. And let's just take a look at a quick example before we do a definition. So if I was talking about taking the square root of 25, now what that really means is what number times itself gives me 25? Now the answer here, probably know, is 5, right? Because 5 times 5 gives me 25. In other words, if I took 5 and I squared it, I get what's inside of the square root symbol, which is 25, right? So when I ask you to take the square root of a number, you're saying what number times itself gives you whatever's on the inside there. Once you take the square root, notice you don't write the square root symbol anymore. You've already done the operation. This leads us to our definition here. And in this definition, we'll talk about the principal square root. When I say principal square root, you might want to think of principal meaning the positive. Right, so the positive square root, or the principal square root of some number a, right, so a is the number, denoted as, I say denoted as the square root of a, right, so it's the square root symbol of a, is the positive number b such that b squared equals a. In other words, it's the number that when you multiply it times itself gives you what's on the inside. Now because we're talking about the principal square root, I'm talking about the positive value there. And this definition kind of follows from what I just talked about above. Right, when I'm talking about a and b, I'm saying take the square root of a. The square root of a, the a is the 25. Right? And then b is the answer. What number times itself, or what number squared, gives you what's inside of there. Right? So all I'm talking about when I say a and b here, don't let this confuse you, is I'm saying taking the square root of whatever a is, gives you whatever b is. B is going to be whatever when you multiply it by itself, right? So b squared is equal to a. So we'll look at a couple examples here. If I said to evaluate, and we'll look at a few of these. Now a lot of these you'll be able to do in your head, but you might be able to use your calculator, and we'll talk about doing that in a minute. If I said to evaluate the square root of 9, now I'm saying when I take the square root, I want the positive value, because the square root symbol is already written for us in this problem. So what number, what positive number times itself, what principal square root, what is the principal square root of 9? Well, what number times itself gives you 9? Well, the answer is 3. Because 3 squared, right? 3 times 3 gives you 9. Make sure you don't write the root symbol after you've evaluated it. How about if I said the square root of 16? All I'm asking is what number times itself will give you 16. Remember, we're only taking the positive number. So square root of 16 is 4. Because 4 times 4 gives you 16. Now in either of these cases, if I was talking about, if I wasn't saying the principal square root, I could still find a number, right? If I said what's the square root of 16, 4 times 4 gives me 16, but also negative 4 times negative 4. So negative 4 is another square root of 16 that we could use, because negative times negative makes it a positive. But because we already see the square root symbol, we're going to always assume that means that we're taking the principal square root. If you're writing the square root into the problem as part of the solving process, that's where you'll take either the positive or negative, and you'll have to check both. Let's continue here. If I said I had the square root of 36 over 25. Now, just a little different. What I wouldn't do is I wouldn't divide 36 by 25. What I would notice is that 36 and 25 are both perfect squares. In other words, I could take the square root of 36 and get a whole number value. Take the square root of 25 and get a whole number value. So if you have a fraction here, you're allowed to take the square root of the numerator over the square root of the denominator. The square root of 36 is 6, right? 6 times 6 gives you 36, and the square root of 25 is 5, so the answer here, we got 6/5. Let's take a look at this one here with a decimal. If I said I had the square root of 0.36, then you might be able to do that in your head, you might not. You know, if you're looking at your calculator, alright, so on your calculator, you might want to try to evaluate this. Usually it's the second key on your x squared, so a lot of people will have a button that looks like this for x squared. The square root symbol will be the one that's above it. To get there, you have to hit the second key on the calculator. So if you're looking at my calculator here, to take the square root of a number, right, I need to say second on the x squared to give me that root that's there. So if I say second and then hit the x squared button to get to the square root, and then let's just say 16 just to show what that would look like. The square root of 16, it gives us out 4, which we knew was the answer here, right, from earlier. So if I'm taking the second, I'll take the square root of 0.36 and hit enter, I get 0.6. So the square root of 0.36 is 0.6 or 0.6 if you want to say it that way. The thing to recognize here is that, you know, the square root of 0.36 is almost like the square root of 36. You might have been able to guess what that was going to be 0.6. But if you didn't use your calculator, you can get there. Now if your calculator doesn't display everything on the screen like mine, you would first have to put in the 0.36 and then hit the square root button to get the square root. Make sure you can do that. You should take a second to do that for yourself right now. We'll look at just a couple other ones. If I said I had the square root of 144. Now, let's say you didn't know it. You'll hit second, square root 144, and we get 12. So that means 12 times 12 gives you 144. It's probably one you should have known. But if you didn't, you know, make sure you check it on your calculator. And notice these are all coming out, you know, evenly. Now if I put this one here, if I set the negative square root of 100, keep in mind that negative is out in front of the square root. It's not part of the square root. So when you go to look at this, the negative will stay in front. And then you're just taking the square root of 100. Well, the square root of 100, what number times itself gives you 100? Well, that number is 10. So the answer here will be negative 10. Make sure you keep that negative in front because it stays in front. Now these all were perfect squares. In other words, when you evaluated them, you know, you've got exact answers that, you know, had terminating decimals or that were integer values. They stopped. If I said in this example to approximate square root of 7 to 3 decimal places. Now, the first thing you should think of is the square root of 7 is not a perfect square. And you should know that basically because you don't know of a whole number value times itself that'll give you 7. Now, you could kind of approximate where it should fall, right? The square root of 7, well, what's a perfect square that's, you know, closest to 7 below it? Well, you can think of like the square root of 4, right? Because 7, you know, 4 is the perfect square that falls right below 7. So the square root of 4 would be 2. And you could think of, well, what's the square root of a perfect square above 7? Well, the closest perfect square to 7 above it would be the square root of 9, which is 3. So we know that this should come out somewhere between 2 and 3, because the square root of 4 would give us 2, the square root of 9 would give us 3, and the square root of 7 would fall in between them. Now, we don't know what it is exactly, so we're going to approximate it on the calculator. Squiggly equal sign is an approximation symbol, and if I take the square root of 7 on here and hit enter, I get 2.6457. We're rounding to 3 decimal places, so that 7 will tell us to round that 5 up 1, right? Because the 5 or above, we'll round the place up. So 3 decimals is 2.64, and we're rounding it to 6. So 2.646. This is what we would call the approximation. If I ask you for the exact answer, the square root of 7 is actually the exact value. We can't be more exact than that. So the decimal is always the approximation. The square root, if it's not a perfect square, you want to leave it as a square root for the exact value. Let's take a look at just a note here that'll help us going forward. So for this note, we're going to say note the square root of a negative number is, and maybe I'll show an example first. Suppose I said the square root of negative 25. Now be careful, it's not the square root of 25. If I just said the square root of 25, you know the answer would be 5. But the square root of negative 25, think about what that means. Saying what number times itself would give me negative 25. Well, if you thought it was, 5 times 5 just equals 25. So we know it's not 5 because we can't get a negative out of that. Maybe you think it's negative 5, right? Because the square root of 25 would be 5, so maybe you think negative 5. But if you put negative 5 times negative 5, a negative times a negative, well, that makes it a positive 25. So that's not going to work either. And the truth of it is that we don't have any real numbers that can multiply times themselves to give you a negative, right? Because a positive times a positive will be positive, a negative times a negative will be a positive. So there's no number times itself that's a real number that will give us here. Later on we'll talk about what we call imaginary numbers, but for right now, we can't find a number that does this, so we say that this is just not a real number. As we get further into the course, we'll talk about imaginary numbers, which will help us evaluate this. But for right now, in this introductory section, we'll just say is not a real number. So for this first section, that's all we're asking you for. If you've heard of imaginary numbers before, you might have heard of the number I, and you can use complex numbers to talk about square roots and negatives, but we're not there yet. So for right now, just keep in mind if you have this negative underneath the square root symbol, that's going to be not a real number. If the negative is on the outside, like we saw, in example F on the previous page, that's no big deal. The negative stays on the outside, right? You keep it there. So let's talk about cube roots. All right, so this is another definition here. So we talked about square root, which was a number times itself to give you whatever was on the inside of there. For the cube root, the cube root of a number A denoted as cube root A. So the little 3 here, we call that the index of the root. So a little 3 here is the cube root. For a square root, we don't actually write anything there, but you assume it's a 2, meaning, what number times itself, what number squared gives you whatever's on the inside. So the cube root of a number A, denoted as cube root A, is the number B such that B to the third power is equal to A. In other words, what number times itself 3 times, or what number to the third power gives you what's on the inside. So it's a similar definition to what we had earlier. Let's take a look at an example. So if I said to simplify, and we'll look at the cube root of 8. So what we're really asking is what number times itself 3 times, or what number to the third power would give me 8? Well, the cube root of 8 is equal to 2, right? Because 2 times 2 is 4, times another 2 would give me 8. So the answer here is 2. You can also think of it as the reasoning is because 2 to the third power equals 8. You don't have to write the reasoning here every time, but this is the reason why this is true, right? 2 to the third power equals 8, so the cube root of 8 is 2. If you wanted to try it on your calculator, maybe you weren't sure on your calculator, typically it's going to be a second key, just like it was earlier, usually on the power button. So your power button might look like that, or it might look like something like, an X to the Y or a Y to the X, but it's usually the second key, the thing above it, and it'll look like this, the X root, or it might, look like this, something like that. On my calculator, it looks like this, and this is the second key, remember, to get to here. So if I want to take the third root, or the cube root, right, that's the index. So the way it works is you actually have to put in the root that you want to take first. So I want to take the third root, I'm going to put 3, and then see there's my my little caret button to do the power, but the second key on there is, see the Nth root, so 3 is the root, you hit the second, and then the root button, and then the value you want to take that root of is 8. I guess I don't need that parenthesis there. So the cube root of 8, and it gives us 2, which is what we knew it was supposed to be. If your calculator displays everything on the screen, you might have to type in the number first, then hit the second key, and then the root button, and then the root you want. So you have to do it in the opposite order. Let's talk about the next one here. If I said I had the cube root of -27. Now be careful with this. The common mistake people make is they sometimes will say not a real number, because it was not a real number if you have the square root of a negative value. But the cube root of a negative number can be negative, because remember, the reason this didn't work is that when you multiply two numbers together, whether they both be positive or both be negative, you're going to get a positive out. But here, when you multiply a number times itself 3 times, in order to get a negative, that number is going to have to be negative, because you need an odd number of negative signs. So we know the answer here should be negative to get a cube root of negative, because the index is odd, right? Because we multiplied 3 times. And what number to the third power will give me 27? Well, that number is 3, so the answer here is -3, right? So a cube root of a negative will always stay negative, and then you just take the cube root of the value, which is 27. The reason, because when you take a negative to an odd power, that's going to stay negative, because a negative times a negative times another negative. So a negative times a negative would make it a positive, times another negative would make it a negative. And 3 times 3 times 3 is 27, so you get -27. If you're not sure, you can use your calculator, second cube root, right? So 3, hit the second key to get the root. So third root of -27, and we get -3, which is what we knew it should be. You might want to try this next one on your own, just to make sure you got it. If I said the cube root of -1000. So I want to pause it here just for a second. Alright, so the cube root of a negative number, since it's an odd index, it'll be negative. Alright, the cube root of 1000. Now you should know what that is, but if you're not sure, you can use your calculator, but it's going to be -10. And the reason is because -10 to the third power will give you 1000. So knowing that the odd index of a negative number will stay negative is helpful, because then you just have to worry about taking the root of whatever the absolute value is of that number. All right, and keep the negative in front, and then you're just left with the value of that root. Remember, once you take the root symbol is gone. Don't keep writing it. And let's talk about just in general. So I talked about square root, I talked about cube root, right, the index of the root. In general, the nth root of a number a denoted as nth root of a. So when I say nth, n is the index. So square root was 2, cube root was 3. You could have fourth root, fifth root, whatever, but the nth root is the index. Is the number b such that, now remember this is just in general, but it's whatever the number that you get out here, whatever that is to the power of the index gives you what's on the inside. So such that b to the nth power is equal to a. So we're really looking, when we take the nth root, we're saying, okay, if I'm taking the nth root of it, what number to that power will give me what's on the inside. And then just a quick note, I kind of referred to it already. If n is even, right, so if the index is even, like the square root, then a must be a positive number. To have a real answer. And that's because you couldn't use a negative number to get a real answer, because a negative times itself an even number of times would turn out positive. Alright, so if the index is even, then the inside here would have to be a positive number to get a real answer. Let's take a look at some examples here. So I already wrote these out. I think what you should do is take a look at these, pause the video, work through these ones on your own first, then unpause it to make sure that you get the correct answer. Now you can use your calculator here. You may or may not need to, but then unpause and we'll come back and finish these out. So taking a look here, the first one we have is the fourth root of 81. Now that means what number times itself 4 times, or what number to the fourth power would give me 81. Now looking on the calculator, it might be easiest just to take this as 4 is the index of the root, so the fourth root of 81, and hit enter, and we get 3. So it's really saying the answer here is 3. Remember, you don't write the root symbol after you've already taken it, so it's saying 3 to the fourth power would give me 81. Let's take a look at the next one. The next one is the square root of 49. So what number times itself would give you 49? Or what number squared gives you 49? Well, the answer there is 7. The cube root of 64. Be careful here. 64 is a perfect square, meaning a number times itself can give you 64, but also it's a perfect cube, meaning a number times itself 3 times, or a number to the third power gives you 64. So make sure you're taking a look there. The cube root of 64, make sure you put in the correct root. Right? The cube root of 64 is going to give us 4. So this equals 4, which means 4 to the third power gives you 64. Don't put 8 here. Sometimes you'll take the square root by mistake. The square root of 64 is 8, because 8 times 8 gives you 64. What's the fifth root of negative 32? Well, the important thing is noticing you have a negative on the inside will tell you that the answer should be negative. And we're saying what number to the fifth power would give me 32? In case you're not sure, alright, the fifth root, you hit 5. Then the index, remember, if your calculator does not display it on the screen, you might have to put the argument in first, the negative 32, and then take the root. So fifth root of negative 32. Now I already know it's going to be negative, so I'm just going to put 32, because I know the negative is going to be there no matter what. The fifth root of 32 is 2. It's negative because we know it should be a negative to get a negative answer on the inside when you raise it to the fifth power. So the answer here is negative 2. Now if you wanted to write negative 32 in here, that's fine. But sometimes it's easier to take care of the sign on its own because you make a mistake in the calculator. What's the square root of negative 49? Well, what times itself will give you negative 49? Well, in this case, it's an even root of a negative. We know that's not a real number. Now, you may have tried to put that into your calculator, and if you did, just take a look at what happens. So, it would be the square root of negative 49. Domain error. Now, don't write domain error. All right, if you write domain error as your answer, I know you don't understand what you're doing. That's calculator speak. We're just saying that you can't take the square root of a negative number, but the answer is not a real number. Now for the cube root of negative 125, well, what number times itself 3 times will give you a negative 125? We know for an odd root, a negative in here is okay, it can be negative. And what number to the third power gives you 125? Well, the answer there is 5, so we've got negative 5. You can use your calculator if you weren't sure. Next one, the sixth root of 15,625. That one we'll use on the calculator. So sixth root, we're going to put 6 as the index. Take the root, so sixth root of 15,625. End up with 5, so the answer here is 5. So 5 to the sixth power would give you 15,625 is what that's saying. And now you've got the fourth root of 16 over 625. Don't divide this first. 16 and 625, they're perfect fourth powers. This will work out nice. So the fourth root of 16 over the fourth root of 625. Remember, we kind of referred to this on the first page. If I'm looking at that, the fourth root of 16, you should know it, but in case you didn't, right, take the fourth root of 16 gives us 2, right, because 2 to the fourth power gives you 16. Remember, once you take the root, you don't write it in there anymore. And the fourth root of 625, that gives us 5, so we get 2/5 as the answer there. So hopefully you're able to practice those on your own and get those answers. The very last part of this section has to do with a definition. So let's take a look at this definition here. So this definition is related to square roots. It's something that, you know, comes up later in math, but you should understand it. So if I said for any real number a, the square root of a squared, whether a is positive or negative, is equal to the absolute value of a. Now remember what absolute value means. It means takes the positive of whatever a is. So let me give an example of what this means, because sometimes people see this and it's not. Sometimes people say the square root of a squared is just a by itself, and that's not always true, and we'll show why. So for example, if I said I had the square root of -4, the quantity squared, well, that's going to be the square root of, what's -4 squared? Well, negative times a negative makes it a positive. 4 times 4 is 16, so it's the square root of 16. Well, what's the square root of 16? The square root of 16 is 4. So when I took the square root of -4 squared, I got the absolute value of whatever was being squared in here, right? The answer wasn't -4. The answer is the square root of 16 is going to be a positive 4. So that's what we're talking about when I say the absolute value of a, right? A is the -4 in this case. So this is really the absolute value of -4, which equals 4. So it's a shortcut to figure out what this answer is going to be. You don't want to just say it's always going to be whatever the base was. So if I said the square root of 4 squared, right, that's going to be the square root of 16, because 4 times 4 gives 16, and then the square root of 16 is 4. Now in this case, yeah, it did end up being the square root of whatever this was being squared, right? Just gave you whatever the base was, gave you positive 4. But the reason is because you have the absolute value of 4, which is equal to 4. So this is positive, yeah, it'll stay positive. This is negative though, when you're squaring it but then take the square root, you're going to get the positive answer out. So a shortcut way of thinking about this based on this rule is saying the square root of -4 squared. The common mistake people make is they just say -4 because they think the square root and the squared cancel. But in this case, they don't. The -4 squared gives you a positive 16. Taking the square root of that gives you a positive 4. Another way of saying it is the rule, which says the absolute value of -4 equals a positive 4. So the answer is positive 4, which we showed there, but just showing, you know, this is what the rule is saying to do. Just take the absolute value of the base. So we'll just look at a few examples. So if I said, to simplify, if I said the square root of x plus 3 squared, first off, don't FOIL this. Don't try to expand it. Don't try to, you know, do x plus 3 times x plus 3, and very much don't bring the 2 into here because you're not allowed to do that with a positive sign in there. So you get the square root of something squared. Well, what's this say? When you have the square root of something squared, you just take the absolute value of whatever that base was that was getting squared. So it's going to be the absolute value of what's getting squared? Well, it's x plus 3. And then you leave it like that. There's really nothing else to do with that. Alright, so the next one. If I said I had the square root of 2x minus 3y, the quantity squared. Again, don't square this. Don't multiply it by itself. What you really want to do is say, okay, if the square root of something squared, you can't just cancel the square root and the square. We really have to say it's the absolute value of whatever the base was. So it's the absolute value of 2x minus 3y. And then close it off. Now, when you have absolute value here, don't try to change this negative to a positive. That's not what absolute value means. The absolute value is saying if the number itself, right, if this was just a number and it was a negative, you would take the positive of it. Or if you had a positive number, it would just stay positive. But when you have, you know, operations inside of the absolute value, you can't touch them. You can't change them. They are what they are. So it's just the absolute value of 2x minus 3y. We don't know what that's going to be, so you have to leave it as is. We don't, in other words, once you substitute a value in for x and y, we don't know if it's going to be positive or negative. You can't just change the sign in the middle of it, though. It won't be the same value, right? If this was just 2 minus 3, that would give you -1. But if this was 2 plus 3, that would give you 5. They're not the same answer. You can't just change the sign, in other words. And we'll look at one more. This is kind of a special case, just seeing if you recognize it. If I said the square root of a squared minus 8a plus 16, This looks a little different, but if you can write this as a perfect square, we can use our rule. So the first thing you might want to do is say if I have a squared minus 8a plus 16, you might recognize this as a perfect square trinomial. This is really the square root of, if I factored this, right, it would be multiply a times a in the front, multiplies with positive 16, adds to a negative 8, so this would be minus 4 and minus 4, right? Negative 4 times negative 4 gives you positive 16, negative 4 plus negative 4 gives you a negative 8. Well, that means I can write a minus 4 times a minus 4 as the square root of a minus 4 squared in there. And what's our rule say? If we have the square root of something squared, you can just write it as the absolute value of whatever that base was that was getting squared, so absolute value of a minus 4. Again, don't change that to a positive sign, right? That's not what absolute value means. It doesn't mean change the signs. It means the absolute value of the number is that number's distance from 0, but you can't change it if you have an expression in here, right? If it was just a single number, that's when you would evaluate the absolute value part. But right now, you just have to leave it like that. So it's a rule that comes in handy as you go throughout math, but it's not used that often. But it's important to remember, because you don't want to just cancel the square root with the squared on any of these, which is what the common mistake is, right? Because you could end up, if you canceled the square root and the squared here, you'd say the answer was negative 4. But we can see that's not right. And the same thing on these. You don't want to just cancel the square root and the squared. You need the absolute values in there. So hopefully this was a good introduction to roots and radicals. In the following sections, we're going to actually do some operations on them.